Yeah. All right, it doesn't interfere? No? All right, okay. Okay, do you studied it? Yeah. All right then. Okay, so we're gonna have a little bit of revision about what we have been doing. Okay, and when you do this topic, the most important thing is the remainder theorem and the factor theorem. Okay, so if you know how they work, and if you know how to state them, then yeah, it's okay. Yes.
Factor remainder.
Factor theorem. Yes. It's okay. Okay, so we have the remainder theorem and we have the factor theorem. Okay, so you know that the remainder theorem is really, really good if you want to find the remainder. Okay, so we know that there are two ways that you can do that. One way is doing the long division, and the other one is doing or using, this theorem. Okay, this theorem says that if px is divided by x minus a, comma, p of a is the remainder. Okay, so that is what the remainder theorem says. The factor theorem says this. Okay, so if p at a is equal to 0, then x minus a is a factor of p of x. And this works in both directions. So we can say if x minus a is a factor, then p at a is equal to 0. Okay, so it can work in both directions. Okay, and then we say that fundamentally what we are doing is to factor, a polynomial. That is the main thing, is to be able to factor a polynomial, so then we can sketch and find the zeros. Okay, that is one of the things that we use the factor theorem for. And the other thing is to solve equation of higher degree. Okay, so the other day we did a few examples. Today we're going to do a few more, and then we're going to go through some of these questions from 28.5. 28.5 from the polynomial chapter. So we're going to go through some of these questions. We did some already. I gave you some for homework, so yeah, we're going to do some of the questions that looks a little bit complicated. And then we're going to move on to the next section, which is the roots and coefficients of polynomial equations. But let's concentrate on this for now. Okay, so we are going to solve the following equation. Okay, let's say that you have this equation. X cubed plus 4x squared minus 7x minus 10 equals 0. I'm going to put another one in here. So let's say that you have 2x cubed plus 3x squared minus 23x minus 12 equals 0. All right, let's say that we have these two equations. Okay, the first one is a monic, and the second one is a non-monic. Okay, and we need to find the value of x that will satisfy the equation. Because it's a cubic, we are expecting to have three solutions, three real solutions. But unfortunately, not all the time all solutions are real. Remember that I explained to you that sometimes we have a picture, and we have a picture that is something like this, go like that. So that means that we have only one real solution. We still got three solutions, but in this case, one is going to be real, and the other one complex. Okay, but when you have cube in there, you always expect to have three real solutions, but that doesn't happen all the time. All right? Okay, so let's solve the top one. Say solution. Okay, firstly, you know that we have to find the factors of -10. Okay, and we have few of them. So we're going to say factor of -10 plus or minus 1, and then we have plus or minus 2, and then plus or minus 5, and then plus or minus 10. Okay, so we got 1, 2, 3, 4, so we got 8 factors. And then we need to check, if we are lucky, we can find one of the factor straight away. So then when you substitute that into the equation, the answer is equal to 0. Okay, so we're going to check positive 1 and see what happens. All right? So we're going to say let p of x equal to that polynomial. And then we're going to check what happened for 1, for example. Okay, so let's check. So p of positive 1, that will give you 1 plus 4. Okay, so it's going to be 5 minus 17. So it's not equal to 0. Okay, so that is so clear. So that is not equal to 0. And then can you please check -1? I want to check p at -1 and see what happened. Okay, so that is like good news. Okay, because p at -1 is equal to 0, then we know that x plus 1 is a factor. Okay, so we're going to say therefore x minus 1 is x plus 1, sorry, is a factor of p of x. And then we're going to do what we done previously. So to find the other factors, to find the other factors, and therefore the other roots, the other zero or roots, we do long division. All right, so we're going to have to divide that long polynomial by x plus 1. All right, can you please, yes? Yeah, I did put the wrong polynomial. So it's x cubed plus 4x squared minus 7x minus that. Yeah, much better. Okay, so I want you to do the long division and then tell me what the answer is. And if you have done the long division correctly, then you know that the remainder have to be equal to 0. Okay? Okay, can you please tell me what is the answer for the question?
X squared plus 3x minus 10.
Minus 10. Okay, and the remainder obviously is equal to 0. So therefore, my polynomial now is equal to x plus 1 multiplied by x squared plus 3x minus 10. Okay, and then we have to say, or we have to see whether we can factor this trinomial. Can we factor this trinomial?
Yes.
Yeah. Okay. Can you please tell me what the factors are?
Negative 2 and positive 5.
Okay, so it's x minus 2 and
Plus 5.
x plus 5. Okay, that's it. So I mean that solving this equation, solving the original equation is the same or equivalent to solve this equation now. X plus 1, x minus 2, x plus 5 equals 0. Okay? So this expression is identical to this one, except that in here is given in factor 4. Again, then from here we can see the 3, 0. So therefore, x is going to be equal to -1, +2, and -5. All right, that's it. So you can see that finding the answer for an equation like this is not too bad. Okay, and also the equation will be given in such a way that the answer is going to be all the time a whole number. Okay, because well, in real life, the whole thing is much more complicated. Sometimes, you know, the answer is going to be a fraction, and then finding factors that a fraction is a little bit more complicated. Okay, in the same way, we can do, you know, equation 2. So we're going to find the solution for this equation. Okay, by the way, this is really, really good because you know that -1 satisfies this equation. +2 also satisfies that equation. So if you substitute 2 in here, the answer is going to be 0. And then you know that -5 also satisfies this equation. Now, to put this into a real-life context, this is great because let's say that you are modeling some phenomenon, okay, some physical phenomenon in real life. And you need to forecast what's going to happen, you know, eventually in a particular point. So if you have the equation, in here you have 1, 2, and 3 solutions for the same problem. If you apply this to a real-life situation, maybe, you know, one of these solutions doesn't make any sense, but at least one of them probably will solve your problem. All right? Okay, so you got to remember that when we are doing mathematics, it's not just because we just want to do mathematics, but it's because of the application in real life. Okay, now, equation 2. Okay, so can you please solve that equation? Okay, so we're talking about this polynomial now. And then you have to find the factors of -12, which are negative or +1, negative and +2, and so on. Okay, so you know what they are. Okay, so I really want you to find the one that will give you 0. Do you find any?
Yeah. 3.
Positive 3?
Mm-hmm.
Okay, positive 3. Has anyone found a different one?
Yeah. -4 works as well.
-4? Okay. So. Right. Can you find any other? So we have 3 is a 0, -4. I think that we should have another one. All right, I'm going to show you something. Okay, so in here we're saying that P of 3 is equal to 0, and also we're saying that P at -4 is equal to 0. Okay? All right, so if P at 3 is equal to 0, then we can say that x minus 3 is a factor. And for the same reason, we can say that x plus 4 is a factor. And then to find the other factor, we can do it this way. So I want you to put your pen down and listen to me for 1 second, okay? So to find the other factor, we can do this. We can divide this polynomial by x minus 3 and do what we did before. Or we can divide this polynomial by x plus 4, and then we do the long division. Or the other option is, because this is a factor and this is another factor, then we can say that x minus 3, x plus 4 is also a factor. Okay, so if this is a factor and this is another factor, then we can say that the multiplication of them is also a factor. Okay, this will help you to do long division quicker. Okay, and I show you how. Okay, so what we're going to do, we're going to divide this polynomial by this. Okay, but to do that, we're going to expand this. Okay, so I'm going to expand this. So can you please expand this and tell me what the answer is? I want you to do the multiplication and tell me what the answer is. Okay, so you do x minus 3 multiplied by x plus 4.
X squared plus x minus 12.
That's correct. Okay, so x minus 3 multiplied by x plus 4 is equal to x squared plus x and then minus 12. Right? And then what we're going to do, we're going to divide this polynomial by that. All right, so okay, can you please do that division? Okay, so if you do the long division in here, you're going to have another expression, and that expression is going to be the other factor. Do you find it?
It's 2x
2x
plus 1.
plus 1.
Yeah.
Yes.
But I did that without having
Yeah.
to do that.
Hmm?
I got that answer without having to do that.
Then
I
you-
did it the other way, like with the long multiplication, and just got the answer.
yeah.
Yeah.
Okay, but let's say that for some reason you actually did the long division. Okay, and then you got 2x plus 1. Okay. Okay, so I mean, that means that the original equation is also equal to x squared plus x minus 12 multiplied by 2x plus 1 equals 0. And we know that this is equal to what we had before, so we have x minus 3, x plus 4, and then 2x plus 1 equals 0. And then from here we had, the 3 zeros.
So is that like the complex one?
No, it's not complex. It's just negative r.
Oh, right.
Yeah, no, they're all
Yeah,
real.
no.
Okay, so therefore the solutions are, and we have, again, we are lucky, we have 3 real solutions. So the first one is 3, -4, and the other one is -half. Okay, so that means that if you substitute any of this number into, the original equation, then those number will satisfy. Okay, so solving equation of higher degree, it's okay. All right, now from the polynomial chapter that you have, I gave you a copy of the chapter. Can you please open it and go to page 223. 223. Okay, and then I'm going to show you what question we need to do. Yeah, page
Exercise 28.5.
223, exercise 28.5 from the polynomial chapter. Okay, so we're going to look at question 12, 13, and 14. Okay, so question 12. Okay, question 12 say, if p of x is equal to x minus a square and then multiply by x minus b, then the polynomial equation p of x equal 0 has one root x equal b and a double root at x equal a. Okay, I believe that is easy to understand this statement. Okay, so if you have a polynomial that looks like this, and if you make that equal to 0, can you see that you're going to have a double 0 at x equal a, and then you're going to have a single 0 at x equal b? For example, let's say that you have, okay, so let's say, for example, that you have this x plus 3 squared, and then you have x minus 1 equal 0. Okay, so you know that in here we have x plus 3, x plus 3, and then we have x minus 1 equals 0. And in here you can see that we have x equal -3 twice as solution. And then we have +1. Okay, so we have a double root. We have a double root at x equal -3. And then we have a single root at x equal +1. Okay, so that is what this is telling you. That's all what it's saying. All right. But the question that you have to do the following. Okay, part A. Find all factors. Find all factors of P of x equal to x cubed minus x squared minus x plus 1, and show that P of x equals 0 has a double root at x equal +1. And then part B, sketch the graph. Sketch the graph of P of x. And yeah, note the nature of the graph at the double root. All right, so I want you to do this question. All right, let's read the heading, and then let's see how we can do this question. They say if P of x is equal to x minus a to the power of 2 multiplied by x minus b, then that means that the polynomial equation P of x equals 0 has one root and x equal b and a double root at x equal a. All right, so that is clear. So in here I give you an example. If you have a situation like this, so clearly you can see that this polynomial or this factor will give you 2, 0, and this will give you 1. So we got 1, 2, 3, but we have 1 which is double. All right, that's all what it is. Okay. Okay, and then I want you to apply that to answer this question. They say find all factors of this polynomial and show that P of x equals 0 has a double root at x equals 1. And then in here they say that you've got to sketch the graph and see what is going on at that particular double root. Okay? Okay, Natasha, I want you to pause the video for 1 second